Okay, let's look at just a couple more if you like. So here it appears that I have an exponential function. It appears to be something like e to the x, just guesstimating. And so I notice here that when f of x is increasing, actually, this function is increasing on the entire interval, then what do we know about the sign of f prime? Well, we notice that the sign of f prime is positive. When f of x is decreasing, well, that's not happening, not applicable. And we notice that none of these slopes, none of the derivatives are negative either. This graph is concave up. So what could we say about the f prime values? So if we look at them, sorry, this one got a little bit rubbed off. What is going on with these f prime values? We already said they're positive, but do you notice also that they're increasing? The slope is getting steeper and steeper and steeper. And does that make sense? It does. And if you look at this graph, what's interesting, the original function appears to be y equals e to the x. And what does its derivative look like? It looks like it's the exact same function. That's interesting. Okay, last one we'll talk about is you were given this function in blue, which appears to be maybe the natural log of x. And on this one, it was interesting because the function was increasing the entire time. So the function's increasing the entire time. We'll look at the derivative the entire time. The derivative is positive for the entire interval. So positive. Oops, I'm running out of room here. Positive. There we go. Now, this function is not decreasing, so it doesn't apply. Also, notice the derivative is negative, negative, never negative. Now, this graph actually is concave down. Now, look at the y values for the derivative. What are the y values doing for the derivative? They are decreasing. And that means that the slope is getting less steep, less steep. Is that happening? Why, yes, actually, the function is decreasing and is approaching. It looks like maybe like a horizontal asymptote. Not quite sure. Now, this is interesting. This function was natural log of x, it appears. And look at its derivative. It's actually kind of an maybe like a reciprocal function, huh? Okay. Now, can we make some conjectures as to what is happening? So in every example we looked at, when f of x was increasing, what did you notice about f prime? When f of x is decreasing, what did you notice about f prime? When f of x was concave up, what did you notice about the derivative? Oh, I said up, I meant down. When f of x was concave up, what did you notice about the derivative? At a maximum value, so like a graph like this, or a graph like this, what did you notice about the derivative? Well, the derivative was either 0 or does not exist. And how was the derivative changing? In other words, what was the sign of the derivative changing from? What if you have a minimum value? Something like this. Again, what is the value of the derivative at the minimum? And how is the sign of the derivative changing at a minimum value? These are the aha